Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I will be your host for today's video. And for today's video, we will be discussing open systems, and for this one, we will be focusing on compressors. So the problem states that an air compressor receives 5,000 kilowatts of power. The air enters with an enthalpy of 290 kilojoules per kilogram and leaves with an enthalpy of 714 kilojoules per kilogram. The velocity at the entrance is low, while the velocity is 90 meters per second at the discharge. Assume that the process is adiabatic and the potential energy is negligible. Compute the mass flow rate of the air. So for open systems, we have two devices that produces work. So we have compressors or pumps, and they produce positive work. And from this problem, you can see that it's stated na the compressor receives 5,000 kilowatts of power, meaning natanggap niya, and therefore it is positive yung work natin. Or for this instance, it's power, meaning work per time, per unit time. So, ayan. And the other type is turbines or expander. And the work here is negative. They produce negative work. Kasi nga, it expands whatever is inside that device. For an open system, we have an open system energy balance. And here, it states that the heat plus the work in that device or in the system is equal to the change in kinetic energy plus the change in potential energy plus the change in enthalpy, which is delta H. And in this problem, it states that the process is adiabatic, so Q natin is 0. And the potential energy is negligible, so yung delta PE natin is 0. So ang magiging equation natin for this problem is work is equals to change in KE plus the change in enthalpy. And then now, what we're gonna do is we're gonna draw a compressor here, like so. And mas malaki yung diameter niya at the entrance and smaller at the exit. So meron ditong arrow that indicates the air entering, and then here we leave yung air. And from here we know that the work is positive 5,000 kilowatts. And what is kilowatts? It's kilojoules per second. Okay, kasi watts natin is joules per second, right? So yung kilowatts is just kilojoules per second. Okay? Yun yung work natin. Wala tayong heat, so now we're just gonna write the enthalpy at the entrance. And enthalpy, we can indicate H1 for that, and it'll be 290 kilojoules per kilogram. And then velocity at the entrance is low. Kapag ganyan na walang value na binigay, you can just assume that it is negligible. Negligible. Okay? So yung V1 natin ay 0 meters per second. And then at exit, yung enthalpy natin ay 714. And we can use H2 to indicate that. 714 kilojoules per kilogram. And then yung velocity natin ay 90 meters per second. Okay, so nalista na natin lahat ng given here. So what we're gonna do now is substitute it in this open system equation that we found. And from this equation, we know that the delta KE is equals to the change in velocity squared over 2GC. But for SI units, and for this one, we're dealing with SI kasi watts siya, so kilojoules per second. Tapos, ito kilojoules per kilogram. These are all in SI units. So, if we're talking about SI units, yung GC natin is just 1 kilogram meters per second squared per Newton. And we know that kilogram meters per second squared is also equals to Newton. Kasi Newton natin is a unit of force, right? And what is force? Force is equals to mass times acceleration. So, yung GC natin here would be 1 kilogram per meter per second squared times kilogram meter per second squared. And you can see na makakancel siya here. Cancel yung kilogram, cancel yung meter squared, and yung second squared, makakancel din. So, when you're dealing with SI units, you don't have to write GC. You can just cancel it off. Kasi ang value naman natin here is 1. But it's a different story if we're talking about English units. Okay? So, our equation then becomes work is equals to the change in velocity, which is V2 squared minus V1 squared over 2. And then yung plus the change in enthalpy natin, which is just delta H. So now we're just going to substitute the values that we listed down here in this simplified equation. And later we're going to notice that our units are a little bit inconsistent, but it's okay kasi from there we can find the mass flow rate. And ang goal natin here is to find the mass flow rate, which has a units of kilogram per second. So ito yung pinaka-goal natin in this problem. Okay? So yung work natin is 5,000 kilojoules per second, right? And then yung V2 natin is 90 meters per second, and this one is squared. Tapos yung V1 squared natin ay 0 meters per second squared. And it's over 2. Tapos yung delta H natin here is 714 minus 290 is 714 minus 290. And ang unit natin dyan ay kilojoules per kilogram. Okay? And here, ang inconsistent, diba? Ito meter squared per second squared kasi mas-square siya. Pero here, kilojoules per kilogram. We can actually equate these two units here. Okay? We know that joules per kilogram is equals to meter squared per second squared. Why? Kasi ang joules natin is unit of work, diba? And work is force times the length or the distance traveled by the person. So it is in the units newtons per meter, right? And then meron tayong kilograms. Eh ano ba yung newton natin? Yung newton natin is force, which is mass times acceleration. So ang unit natin for mass in terms of SI units is kilogram. And ang unit ng acceleration is meter per second squared, right? And then meron pang another m dito. So yung m mo, kasi squared kasi times mo siya sa another m, so it becomes square. And then yung kilogram dito sa denominator. Ayan. And from here, we can see na makakancel yung kilogram. Ang matitira ay meter squared per second squared. So therefore, we can verify na joules per kilogram is indeed meter squared over second squared. Okay? So yeah, we have verified. So we can actually convert this meter squared per second squared to joules per kilogram. And likewise, itong kilojoules per kilogram ay i-convert natin sa joules per kilogram. So ito, 5,000. Itong kilojoules, actually, we can convert it into joules para lahat sila here ay joules, ang unit ng energy. So 5,000 kilojoules per second, 1 kilojoules, we have 1,000 joules. Okay? And from here, makakancel na yung kilojoules and matitira yung joules per second. And then here, yung 90 meters squared over 2. Actually, we just simplify the value. It's 90 squared minus 0 is 90 squared divided by 2. So that is 4,050 joules per kilogram. Kasi meter squared per second squared siya, diba? And then here, we have 714 minus 290. And the value there is 424 kilojoules per kilogram. But then, kilojoules natin, we have to convert into joules. So 1 kilojoule is 1,000 joules. Okay? So, from here, makakancel na yung kilojoules natin. And matitira yung joules per kilogram. So, sa one side of the equation, consistent siya na joules per kilogram. And then here is joules per second. And dito, makukuha na natin yung units na kailangan natin, which is kilograms per second ng mass flow rate. Okay? So, simplifying the values, we have 5 million joules per second is equal to ito. Pag-combine na natin siya. So, 4,050 plus 424 times 1,000. And the value here is 428 and 50 joules per kilogram. Okay? So ngayon, ang goal here is how do we get kilograms per second? Well, what we're gonna do here is, personally, what I do is, I do trial and error. Paano mapupunta yung kilogram sa denominator sa numerator? Diba? And ang kailangan ma-retain ay yung per second. And dito, naka-per second na siya. So, kung ilalagay natin siya sa numerator, pare-retain yung per second. And kapag i-divide natin ito by this value, magiging joules per second over joules per kilogram. And yung kilogram sa denominator mapupunta sa numerator. So, what do we get? Kilograms per second. So, to illustrate my point, we have joules per second sa numerator, right? And if we're gonna divide this by this value, i-divide siya by joules per kilogram. And here, mariretain yung per second, makakancel yung joules, and yung kilogram sa denominator, mapupunta sa numerator kasi nasa denominator siya ng denominator. So, pupunta siya sa numerator. So, it will be kilograms per second. So, this is the unit for mass flow rate. Okay? So, ang gagawin lang natin is just to divide. We have 5 million joules per second. If we divide that by this, the value here, on the right-hand side of the equation, we have 428,050 joules per kilogram. And here, kakancel yung joules. And like I said earlier, yung kilogram will put us in numerator. So it will be kilogram per second. And that is our mass flow rate. So yung mass flow rate natin ay 5 million divided by 428,050. And that is 11.6808784 kilograms per second. And that is our answer for problem. So, ayan. I hope you learned a lot from today's video. Thank you for listening and stay tuned for the next one. Bye-bye.